This will be for the Khan Academy exercise, limits of piecewise functions. All right, so just a tiny bit of notes before we begin. So if you have a limit as x approaches a certain number, if the number for x is on the boundary between the pieces of the piecewise function, you need to find the one-sided limits using both functions. Okay, so you'll see what I mean by that in a moment. Okay, so here we have our piecewise function. We're trying to find the limit as x approaches -4 from the positive side. So if you're going to x equals -4, all right, here's the x-axis. If you're going to x equals -4 and you're approaching it from the positive side, you're going to use the function where x is greater than -4. Okay, so that's this function right here. So we can ignore this because we're only doing a one-sided limit. So since we're using this function, since we're approaching -4 from the positive side, we want the values that are greater than -4. All we have to do is take the -4 and plug it in place of x. All right, so using 2 to the x, that's just going to be 2, and in place of x, you plug in -4. It's just going to be 2 to the -4. Okay, remember when you have a negative exponent, you just take the reciprocal, and you can change the plus minus sign, not the reciprocal, but you could move it to the denominator and change the plus minus sign on the exponent. So 2 to the -4 is equivalent to 1 over 2 to the 4th, and that's going to be 1 over 16. Done.
11:30.
All right, and the negative exponent property that I used, if you have x to the power of -a, that's equivalent to 1 over x to the power of +a. Okay, and it goes the other way as well. If you happen to have 1 over x to the -a, you can move that to the numerator and change the plus minus sign on the exponent. So that's going to be 1 over x to the a. So that's all that I did after I plugged in. All right, 1 over 16. All right, here we have the limit as x approaches -3. So once again, actually, we don't need the graph for this one here. We're going to x equals -3. This function here is for x between -2 and 1. Okay, but we want it for x approaches -3, so we need the one where x is less than -2. -3 does not fall in that range, so we can just ignore this function. We're going to sub in -3 right here, right there in place of x. All right, so that's going to be 2 times -3 plus 1. And -6 plus 1, of course, that's just -5. Simple. Answer A. All right, here we have the limit as x approaches -3. So notice for x equals -3, it is on the boundary of both functions. This one is for x is greater than -3, and this one is less than or equal to -3. Since -3 is right on the boundary, we have to try -3 on both functions, and it has to match. All right. So for this one here, we're plugging in -3 right there. So we're going to get radical 7 plus -3. And of course, that's going to be radical 4, which equals 2. All right. Now in this function here, Again, we're plugging in negative 3 in place of x. So that's going to be negative 3 squared minus 5. Negative 3 squared is 9, minus 5 is 4. All right, notice I used the parentheses when I squared the negative 3. That's going to be 9 minus 5, which is 4. So when the number for x is on the boundary and you have to plug it in both functions, the answer has to match between both functions for the limit. Okay, if not, that is going to be does not exist. So since we got 2 and 4, that does not exist. Answer D. All right, I hope everyone understands. You only have to use both functions when the number for x is on the boundary. Like here it was x is greater than negative 3, and here it's x is less than or equal to negative 3. Since we had a negative 3 and it's on the boundary, we had to plug it in both of them. All right, here we have the limit as x approaches pi, and we can see for our inequalities that pi is on the boundary for both functions, so we're going to have to sub it in for both functions. All right, so for the top function, sine of x, we're just going to plug in pi in place of x. Sine of pi. And if you don't remember sine of pi, you could do it on the calculator, set to radians, or check the unit circle. But I know that the sine of pi is just 0. But I have to check the other one. Again, since x approaches pi, you're subbing in pi in place of x. So that's going to be pi divided by pi minus 1. Pi over pi is just 1 minus 1, that's 0. Okay, so we got 0 for both of them. So the answer is 0. Now, just so you know, if you get one that's a one-sided limit, then you only have to plug it into the appropriate function. Here we have x approaches pi from the positive side, okay? So we only need the one that has the values of x that are greater than pi. Right here, this is the one that's greater than or equal to pi, okay? Since we're doing a one-sided limit from the positive side, we don't need the one that's less than pi. So you can just plug it in right here. And that would be sine of pi, which we just established a moment ago. Sine of pi is just 0.